So in chapter one, there's a lot of topics like physical chemical changes, types of energy, physical states. We're not going to spend time covering that, but in this lecture notes, slides 3 through 8 kind of cover that information for you to read over. So we're going to start with conversions, numbers in chapter 1, but the physical chemical changes, the types of physical states, and types of energy you'll need to cover on your own, and that's a summary of those is found in slides 3 through 8 at the beginning of this lecture notes. And so when we're dealing with measurements, we have to remember that we have two types of numbers. We have exact numbers and measured numbers. And so for exact numbers, those are numbers obtained by counting. And so if you can count it, then it's an exact number. So for example, you count the number of eggs in a dozen. There's 12, you know there's exactly 12. Whereas if you want to count the number of electrons in an atom, there's exactly, for example, 8. So you know exactly how much of that particular quantity you're counting. So if you can count it, it's exact. Now for certain conversion factors that are within the same system of measurement, and I'm going to escape out of this presentation mode so I can actually annotate on the slide. And so certain conversion factors, they are exact conversion factors. So what we're dealing with is those conversion factors that are within the same system of measurement. Second. Yeah. And so for example, when we go from centimeters to meters, we're within the metric system. So that, since it's metric to metric, it's an exact conversion factor. Trying to get the right thickness. There we go. Now, when we talk about ounces to pounds, ounces is the standard unit, and pounds is the standard or English unit. So since we're going to the same type of measurement system, this is an exact conversion. So there's exactly 16 ounces in a pound. Next, we have 12 inches in a foot. So inch and foot are in the standard system of measurement. So since we're going from standard to standard, this is an exact conversion factor. So as long as you're within the same system of measurement, those conversion factors are exact. So if I was to add a little side note here, so there are two types of measurement systems. We have the metric system and the English, or you can call it the standard system. So the English system is what we use in the United States: inches, feet, pounds, ounces, etc., gallons, quarts, things like that. So all those conversion factors are exact. Now the only metric to English conversion factor that's exact is 1 inch is 2.54 centimeters. So that's the only conversion factor that is an exact metric to English conversion factor. And we'll talk why that we need to distinguish between exact and measured numbers on Thursday when we talk about significant figures. So again, exact numbers you can obtain by counting, or it's a conversion factor within the same system of measurement. And the two measurement systems are metric and standard. Now, measured numbers are numbers that we obtain from using a measuring device. So this device could be a ruler, it could be a scale, it could be a clock, so measuring time, etc. And so things like miles, kilograms, degrees Celsius, these are measured quantities, which means we don't know exactly what the measurement is. So there's some degree of uncertainty with the measurement. So for example, this 50.1 miles, we don't know what comes after the 1 because we don't, it's uncertain. So all we know is it's 50.1. It could be 50.12, 50.13, etc. Same thing with 25.6. We only know this mass to the 10th place. After the 10th place, it's uncertain what it could be. Now, anything that you measure is a measured number. The other thing that's measured number is metric to English conversion factors. And when we talk about metric to English conversion factors, to give you a few of those, we're talking about, for example, how many milliliters in a quart. So there's 946 milliliters in 1 quart. That's a measured number. Or there's 2.205 pounds in 1 kilogram. That's a measured number because it's English to metric. And one other one, 0.9144 meters in 1 yard. So all of these are measured numbers. So these are not exact quantities. So measured numbers, you'd obtain the number by using a measuring device, or it's a metric to English conversion factor. Those are all measured numbers. And so there's some degree of uncertainty in the number. And that's where we get into what's called significant figures on Thursday. So with the English system, when we're talking about weight, we're talking about pound and ounces. For volume, we're talking about gallons, quarts, pints, and cups. Now, since we use the English system on a daily basis, it's understood that people will know how many ounces in a pound, how many quarts in a gallon, how many pints in a quart. Likewise for length, we should know how many inches in a foot, or how many feet in a yard, or how many yards in a mile, not yards, feet in a mile. So those are things that we use on a daily basis that, they may not give you in the book because they expect that you know that information because we use them on a daily basis. So for temperature, the English system is Fahrenheit. Now the other type of system is the metric system, and this is based on powers of 10. So as we'll see on the next slide, when we have different powers of 10, they're indicated by different prefixes. So if you know the prefix that you're using, you can correlate that to the power of 10. For example, when we talk about millimeters, we know that's 10 to the negative 3 prefix. Now for the metric system, for mass, we use grams. So you can have kilograms, for example, micrograms, centigrams. For length, we can have centimeters, kilometers, nanometers. For volume, we know typically we use milliliters, but you can use, there's also deciliters as well. The temperature for the metric system is Celsius. So these are the two different types of measuring systems. Now for the metric prefixes, there's quite a few of them. So you should be able to correlate the prefix to its multiplier. So let me show you how we do that. So for example, when we say kilo is 10 to the third, if we use meter, we're going to say 1 kilometer is 10 to the third meters. So that's how you interpret the name with the multiplier. So kilo means 10 to the third. So 1 times 10 to the third. When we talk about deciliter, 1 deciliter is 10 to the negative 1, or 1 decimeter is 10 to the negative 1 meter. So this is a conversion factor we would use to convert between decimeter and meter. So for a centimeter, the way you would do this is 1 centimeter is 10 to the negative 2 meters. So this multiplier is what's the base unit, and that equals the prefix. So our base unit here is meters. Our prefix is the K, the D, the C in front of meters. And we'll do one more. So for example, nanometers is 10 to the negative 9 meters. Now you may see this written differently. So one way you can write this, 1 kilometer is 10 to the third meters, or you can write 1 meter is 10 to the negative 3 kilometers. So whether you use which one, it's the same thing. It's just different on what you define as 1. If we define 1 kilometer, then it's 10 to the third meters. If we define 1 meter, it's 10 to the negative 3 kilometers. Likewise, if we define 1 meter, it would be 10 to the 9th nanometers. So it doesn't matter which one of these conversion factors you use for nanometers, as long as you pick one, it's just going to dictate which one's going to go on the bottom in your conversion factor and which one will go on top. Now we'll look at some examples of metric to metric conversions. So in the first one, we want to convert nanometers to millimeters. So in order to convert nanometers to millimeters, we're going to do this process. We're going to go from nanometers to meters to millimeters. Now there's more than one way you can do this, but this is the way that we're going to do it. So we're going to take nanometers, convert it to meters, and then take meters and convert it to millimeters. So before we begin, we need the conversion factors. So we know that 1 nanometer is, and I'm going to use E instead of to the power of 10 just because it's easier to write, is 10 to the negative 9 meters. And 1 millimeter is 1 e to the negative 3 meters. So these are the two conversion factors that we're going to use. So now I'm going to draw my train tracks. And set up the problem. So the 33,400 nanometers, I'm going to write in scientific notation, just so it's a little bit easier. So we have 3.34 times e to the negative 4. Now on the bottom in our conversion factor goes millimeter. So 1 millimeter. Because we're starting with millimeters, millimeters goes on the bottom, and then meter goes on top. Now I'm going to do this in 2 steps, just so you can see the process, but you could do it in 1 step if you like. So here the millimeters cancel, and what we have left is meters. So whenever you multiply, you add exponents. So the results here would be, 1 second, 3.34 e to the negative 5 meters. So again, when you multiply two exponents, you add their power. So 4 minus 9 gives us negative 5. So now we have meters. The next thing we want to do is convert it to millimeters. So then we set up our train track again, and we convert from meters to millimeters. So since we're starting with meters, meters goes on the bottom in our conversion factors. So we have 1 e to the negative 3. And millimeter goes on top. Did it backwards, yeah. So now again, when we multiply, we add exponents, and when we divide, we subtract exponents. So here our final answer is, so 10 to the negative 5th divided by 10 to the negative 3 means we subtract, so negative 5 minus a negative 3 gives us negative 2, so 3.34 e to the negative 2. And that's how many millimeters are in 33,400 nanometers. So the way we can check our work is nano is smaller than milli. So since nano is smaller than milli, our exponent should decrease. Our exponent's power should decrease when we go from nanometer to millimeter, and that's what it did. So it's 3.34 times 10 to the negative 2. Now if we look at the next one, we have 0.0056 centigrams, and we want to convert it to micrograms. So the way we're going to do this is we're going to convert centigrams into grams into micrograms. So we need to know the conversion factors for this. So from the chart on the previous slide, we know that 1 centigram is 1 e to the negative 2 grams, and 1 microgram is 10 to the negative 6 grams. And I'm using U for micro because it's just quicker to write than finding the mu. So these are the two conversion factors we're going to use to convert from centigrams to micrograms. So we set up our train tracks. So we're going to start with centigrams. And I'm going to write 0.0056 into scientific notation because it makes it easier to do. So we have 5.6 e to the negative 3 centigrams. And since we're starting with centi goes on the bottom in the conversion factor. And gram goes on top. So now when we multiply, we add exponents. So 5.6 times 10 to the negative 3 times 10 to the negative 2, we add the exponents, it becomes 10 to the negative 5th grams. So now what we're going to do is we're going to convert grams into micrograms. And since we're starting with grams, in our gram to microgram conversion, gram goes on the bottom. And microgram goes on top. And so when we divide, we subtract exponents. So when we subtract exponents, we get 5.6, and it's -5 minus a -6, we get a power of 1. And you also notice that all the units cancel. Centigrams cancels, and the gram cancels as well. And so we're left with micrograms. So here we're just converting normal metric units, but sometimes with metric units and also English units, pop this one up on the, so sometimes with metric units and also English units, you could have squared units. So here we, instead of just converting picometer to micrometer, in this example, we want to convert picometer squared to micrometer squared. So obviously on that chart I showed you a few slides back, there's no conversion of picometer squared to micrometer squared. But from that chart, we know that there's 1 meter is 10 to the 12 picometers and 1 meter is 10 to the 6 micrometers. And so what you have to do is you have to square both sides to get the squared conversion factors. So what you have to remember here is to square the actual exponent. So when you want to square 10 to the 12th, you just take 12 and multiply it by 2. So we get 1 meter squared is 10 to the 24th picometer squared, and 1 meter squared is 10 to the 12th micrometer squared. The most common mistake that students make is they forget to square the exponent and just square the unit, which doesn't help because then we get the wrong exponent power. So now we set it up. We start with picometer squared. In our conversion factor, picometer squared goes on the bottom, meter squared goes on top. And then we want to convert to micrometer squared. Meter squared goes on the bottom, micrometer squared goes on top, so that everything cancels but micrometer squared. So when you multiply, you add exponents. So 10 to the 5th times 10 to the 12th is 10 to the 17th. And when you divide, you subtract exponents. Now you can do this in your calculator. If you do it in your calculator, make sure to use parentheses because it gives you the answer based on order of operations. And so the final answer here is 6.6 times 10 to the -7. Now, since we're going from picometer squared to micrometer squared, we're going from a smaller metric prefix to a larger metric prefix. So therefore, it makes sense that our exponent's power will decrease. And that's what it did here. We went from 10 to the 5th down to 10 to the -7. So again, when you have squared units, it's very important that when you square the conversion factors, you square the exponent power as well. And again, you do that by multiplying it by 2. So another type of example we can have is when we have cubed units. So in addition to squared, we can cube our units and get millimeters squared or feet squared, or excuse me, cubed, millimeters cubed, kilometers cubed, etc. So here we want to go from millimeters cubed to nanometers cubed. So again, what we know is that 1 meter is 1,000 millimeters, and 1 meter is 10 to the 9th nanometers. So what we have to do is we cube both sides. We get the cubed conversion factors. So now when you cube a power, you have to multiply it by 3. So 10 to the 3 times 3 gives us 9. And 10 to the 9th, 9 times 3 gives us 27. So now that we have the conversion factors, we start with 75,000 millimeters cubed. When we convert to meters cubed, millimeter cubed is on the bottom, meter cubed on top. So that cancels out the millimeters cubed. And then we get the second conversion factor, meter cubed is on the bottom, nanometer cubed is on top. So when you multiply, you add exponents. So 75,000 is 7.5 10 to the 4th times 10 to the 27th. That gives us 10 to the 31. And then we divide by 10 to the 9th. So you subtract 31 minus 9, and we get 22. Now to check our work here, we're going from millimeter, which is a larger metric prefix, than nanometer. So since we're going from a large metric prefix to a small metric prefix, our exponent power should go up. And that's what it does here. It goes from 10 to the 4th to 10 to the 22nd. And so that makes sense because we're going from a large to a smaller metric prefix. And one of the most common mistakes is that students forget to cube the exponent. They just cube the unit. So you got to remember to cube the exponent power as well. Oh, with practice problems. We'll do a few of these. Let's see. I'll do number 2 and 3 because 1 and 2 are similar. So we'll do 2 and 3 and we'll go through. So in number 2, we want to convert kiloseconds to microseconds. So again, the way we're going to do this is I'm going to take kiloseconds. And again, there's more than one way to do this. If you have a different way and it works, no worries. Kiloseconds to seconds to microseconds. So notice here that the units are in squared or cubed, so we don't have to square or cube our units. So we're going to need conversion factors. And we know from our table that 1 kilosecond is 10 to the 3 seconds, and 1 microsecond is 10 to the negative 6 seconds. So these are the two conversion factors we're going to use. So now we draw our train track. So we have 9.87 e to the negative 9. This is kiloseconds. So since we're starting with kiloseconds and our conversion of kiloseconds to seconds, we put kilosecond on the bottom. So 1 kilosecond and 1 to the 3rd seconds. Again, you can do this all in one step. I'll do the next one all in one step so you can see it, but here we're doing it in 2 steps. So again, when we multiply, we add exponents. So negative 9 plus 3 gives us negative 6. So this would be 9.87 e to the negative 6. Now that we have kiloseconds, we can convert to, or excuse me, now that we have seconds, I'll change that in just a moment, we can convert to microseconds. So since we're starting with seconds, it goes on the bottom. And microsecond goes on top. So now again, we're dividing. So when we divide, we subtract exponents. So 10 to the negative 6 divided by 10 to the negative 6 is 10 to the 0, and 10 to the 0 is 1. So our answer is just 9.87 microseconds. And this makes sense because, again, we're going from a large metric prefix to a smaller metric prefix, so our exponent should increase. So it should be bigger than negative 9. And 9.87 is bigger than 9.87 times 10 to the negative 9. In the next example, we want to convert picometers squared to millimeters squared. So what we're going to do is we're going to take picometers squared convert it to meters squared, convert it to millimeters squared. And the reason I know we need to square these is because our original units are squared units. So now we need the normal conversion factors. And what we're going to do is we're going to square them. So when you square them, you square the units, and of course you multiply the exponents by 2. So when we do that, we get 10 to the negative 24 meters squared, or 1 picometer squared, and 10 to the negative 6 meters squared, and 1 millimeter squared. Again, when you square, you multiply the exponent by 2, and just a reminder, when you cube, you multiply the exponent by 3. So now we can set up our train tracks. So this one I'm going to show you all in one step so you can see the difference. So we start with (8.75 e to the 12 picometers squared). So since we're starting with picometers squared, from our conversion factor, it goes on the bottom. And meters squared goes on top. Now that we have meters squared, we want to convert it to millimeters squared. So in our conversion factor of meters squared to millimeters squared, meters squared goes on the bottom. And millimeters squared goes on top. And again, notice that all the units cancel out that we need to, and only the unit that we want remains. So when we multiply, we add exponents. When we divide, we subtract exponents. So 10 to the 12th times 10 to the negative 24 is 10 to the negative 12th. And then 10 to the negative 12th divided by 10 to the negative 6, it would be negative 12 minus the negative 6, which would be negative 6. And so again, we're going from picometers, which is a relatively smaller metric prefix than millimeters, so our exponent should decrease. And our exponent power should decrease, and that's what we see here. It decreases in our final answer. So at least we're in the right direction in the size of our exponent.